Yeah, so JWST opens up a completely new way of looking at the universe. It's the most advanced space telescope that we have ever launched. It is bigger and badder and better than Hubble, which was the previous flagship observatory in almost every way. So JWST has a larger mirror, so you can collect more photons, you can observe things that are fainter and farther away. But even with the power of JWST, characterizing the atmospheres of distant planets is still an extraordinary challenge. The size of the signals that we're searching for is less than 100 parts per million, so it's extremely small. Even just the noise from the cameras and the detectors that we use can be larger than the size of the tiny atmospheric signal that we're searching for. Thanks to JWST, we can now gather enough light from these distant planets that with some ingenuity and working together with a big team of students and postdocs all over the world, it's possible to actually detect the atmospheres of Earth-sized planets for the first time. One of the best stars for studying the planets around it is a very special star called TRAPPIST-1. TRAPPIST-1 has 7 small rocky planets in orbit around it, and because the star is so small and so nearby, it makes it much easier for us to study the atmospheres of the planets. And so the whole astronomical community was really excited about TRAPPIST-1 and has been working on it since the planets were discovered almost a decade ago. But previously with Hubble, all we were able to learn about the planets is that they don't have extended hydrogen-rich atmospheres like Jupiter does. So Jupiter's atmosphere is light and fluffy and would give a big signal, but on these small planets, we don't detect any trace of an atmosphere like that. However, there is still a couple of possibilities. So one thing that the TRAPPIST planets could be like is something more like Earth or Venus in our own solar system, with a denser, more compact atmosphere than that of Jupiter. Alternatively, they could have no atmosphere at all. And now finally, with JWST, it's possible to actually detect these more realistic atmospheres on the TRAPPIST-1 planets. JWST has 2 enormous advantages over Hubble for characterizing rocky exoplanet atmospheres. One of them is that it has a much bigger mirror, and so we can collect more light from the planets. And the other is that it allows us to peer into the infrared to detect heat coming off of the surfaces of these smaller and cooler worlds that are much more similar to planets in the solar system. So TRAPPIST-1 is a really small star compared to the Sun. It's less than 20% the size of the Sun. And that poses a great opportunity for us because it allows us to characterize the small planets orbiting such a small star. However, it can also be dangerous for the planets. So we think that these small stars are very bright in the ultraviolet in their early lifetimes, which can evaporate the atmospheres of any planets that are forming there. The stars are also more active. They have flares that can erode atmospheres of planets. And so it's kind of a blessing and a curse, these small stars, because on the one hand, it's easier to study the planets that they host, but on the other hand, their atmospheres may be in grave danger. So one of the very first planets that JWST set its sights on was TRAPPIST-1b, which is the innermost rocky planet in the TRAPPIST system. And the observations observed the planet as it passed behind its host star, and any heat coming from the surface of the planet was blocked as it moved behind the star. And what the observers saw was that the day side of the planet is incredibly hot, indicating that there's no atmosphere that could possibly circulate heat around to the night side of the planet. And so our conclusion is that TRAPPIST-1b is most likely a bare, rocky surface with no atmosphere to speak of. And of course, I'm on team atmosphere, so I was really excited to search for any atmosphere that was there. But the fact that there isn't one is still extraordinary, that we are even able to measure this at all. We've been waiting for decades to answer this question, and now finally with JWST, we have the opportunity to. Coming up next is TRAPPIST-1c, which is the second planet from the central star. And TRAPPIST-1c is really exciting because it's very similar to Venus in our own solar system. It's almost exactly the same size and the same temperature as Venus. And so we observe the planet searching for a Venus-like atmosphere. And in this case, we do not detect a very thick carbon dioxide atmosphere like Venus has. But it's possible that the planet has a small hint of an atmosphere, so it can't have very high surface pressure, can't have very much carbon dioxide, but it's possible that a little bit of atmosphere has remained. So we have just begun our exploration of the TRAPPIST-1 system. There are 5 more planets that have yet to be observed, some of them cooler and even in the habitable zone where liquid water could exist. These planets are all scheduled to be observed by JWST during its first year of science operations. And so I can't wait to see what comes from these measurements. I'm still on Team Atmosphere. I'm rooting for some potential water on these planets, but putting on my objective scientist hat will just observe them and see what we find.